Hello, so it's Michael here, and today I thought I would do something a little bit different, so something a little bit more fun. So we're in one of my test levels, and what I thought I would show you how to make today is a mechanic that is very similar to like the Weeping Angels, and probably more recently the Creaking from Minecraft. So Weeping Angels is from Doc 2, if you've not watched it. Definitely worth checking out, and I'm sure you've probably heard Minecraft. In terms of what this mechanic is, it's when something essentially stops moving when it's being looked at. So when it's being observed. So it's quite a popular mechanic, it's quite fun. So I thought I'd give it a try myself, and I've come up with a system that I think is easy enough to implement, and yeah, offers a lot of room for interpretation in terms of how you want to use it, tweak it, all that type of stuff. So we're currently at a level at the moment where I have got this sort of system set up, so I'm going to give you a quick demonstration of what we're hoping to teach you how to make today. So I have added a few additional systems within this this project, one of which is a global clock system that I've been working on. So I've kind of set mine up where it doesn't actually function as a Weeping Angel type of thing until it gets past sunset. So at the moment we are in the morning, so it's not going to do anything. But if I was just to fast forward time a little bit to sunset, so some light should pop on. There we go. Now you'll probably notice the very peculiar looking white cube cuboid that's just stood there, and I am currently looking at it, so it's not currently moving. But the moment my character looks away, it starts to chase me. I look back at it and it stops. So I have got this set up currently where it's based on the actual character's viewpoint in a sense. So it's not the camera per se, but the actual actor. So again, run away, and if it reaches the character, it pops and dies. So yes, that's the sort of thing that we're going to go over today. Okay then, so before we actually jump into the meat of the tutorial, as it were, there is one thing I kind of want to go over first. So a common thing that I have seen a lot of people doing is actually using the was recently rendered node. So I'm just going to open up the Weeping Angel that I've got there at the moment, and on tick, what I'm going to do is just do a quick print string, and I'm actually going to print the result of the was recently rendered, and then hopefully you'll be able to kind of see why it is that we won't actually be using this at all in the setup that I'll be showing. So if I go ahead and start playing now, you'll notice that if I look at it, it says true, and if I look away, it says false. Now this of course has its pros and cons. If it's more like a first person type game, then you might be thinking, oh great, I can just use that, that's kind of what I want. The third person setting, obviously it's not quite how we'd want it really. Generally probably want it based on the actual character. However, there is actually another issue. So when we say was recently rendered, it's not actually what you think it might be. So if I was to come over here, for example, and look at it, you'll notice it's still saying true, but we can't actually see where it is at all. It's obscured by the wall. So we can see if I move the camera again, and go back there. And if I was to come up through here, so we're even further away, so in this little cave area, there's actually no way that I would ever be able to visibly see that particular angel, but you can see there it's still showing as true. And the reason why is because was recently rendered, what it actually means is, was this actor recently sent to the GPU to be rendered? Now, this might not make much sense on its own as an explanation, so I'm going to kind of explain a little bit more as to why that particular node isn't actually what you want. Hello, so it's Michael from the future. So upon listening back to my explanation, I came to the conclusion that it was, all honesty, terrible. So instead of attempting to explain it again, I have actually found this wonderful video by Crash Course that explains how the rendering side of things actually works. So what I'm going to do is actually link to that in the description. So the name of the video is here, as I mentioned, it's by Crash Course. So if you are wanting to know a bit more in depth about that side of things, you can go ahead and check that video out. Highly recommend it, it's very informative. So other than that, let's get back to it. Okay then, so I've just jumped into another level. It's just a graveyard level, you know, set the scene type of thing. So there's nothing special in here, it's just some meshes dotted around, nothing fancy, with a sky and things like that in it. So with that done, let's go ahead and start. So I'm going to go ahead and just create a folder in here. I'm just going to call that one tutorial. You can obviously put this wherever you like. And in there, I'm going to go ahead and start by creating an actor component. And I will go ahead and call this one InView component. And I'm just going to add a suffix at the end called touch, just so I know that this is the tutorial version. Just because I am in the same project as the example that I showed at the start. Now, with this, we go ahead and open that up. So the first thing we're going to do is go ahead and create a new function, and I'm just going to call this one check nearby. And what this function is going to do is it's going to essentially check for nearby actors and then check some things about them to determine whether or not that thing is looking at whatever we place this component on. So with that function created, I've gone ahead and jumped into the main event graph, and we can just connect that onto event play. Like so. And then we can jump into the create nearby, and we want to start setting up some logic in here. So the first thing we're going to do is create a sequence node. The reason why is just to help keep things a little bit tidier, and we can kind of branch off it. So the first thing we want to do is we want to get all of the actors within a specific range of the owner of this component. And once we've done that, we can then do some checks on them. So the first thing we want to do is a multi-sphere trace. So do sphere trace. Now you've got a bit of flexibility here in terms of which sort of trace you want to use. I'm going to go ahead and use the for objects one. You could always use the channel one if you wanted. The reason I'm going to use the for objects one is because we can specify the object types. I'll just do a make on this, a make array, and I'm just going to choose pawn. So we're going to assume that the only things we want to consider that can be looking at this is pawns. So that's going to be characters and possibly other pawns that you might have created. What we then need to do is define the radius. So I'm just going to promote that to a variable. I'm going to call that one search radius. Again, you can call this variable whatever you want, but you can kind of think of this as how close something has to be for this to consider it as being close enough to determine whether or not it's being looked at. In terms of the radius, you can set this to whatever you want, whatever you like, really. Start with 2000. Again, this is something that can be tweaked per owner that this component's attached to. So it's completely up to you what sort of value you want to set. Now, in terms of the start and end, what we want to do is get the owner. Now, we do want to make sure that it is the actor component version. So if you can see that it says target is and it says actor component. So we want to make sure it's that particular version. What we then want to do is, from that, we want to get the actor location. So we can do the get actor location, and we connect that to the start and the end. Like so. And what we can do is then just connect this on the then 0, like so. And then we just want to go ahead and on the out hits, we just want to promote that to a local variable. Let's call that one hit results. So at this particular point, we don't need to worry about doing anything else with this. However, what we can do is we can come in and there is the debug options. So if we just do this as for one frame, we can set something up where we can sort of test that. So in here, I'm just going to go ahead and create another blueprint class. And this time I'm just going to use the character BP Weeping Angel Tut. We'll come into here, and then we can add that in view component. So I'll be using the component, the tutorial version. So with that selected, you can see the search radius is listed in there. Just as a part of this particular character, I am going to go ahead and select the mesh as well, just so we've got something visible. And I will go for Manny. We'll move him down a little bit. It's around 87. There we go. And we can. I'm not going to bother setting the anim class just yet, but we will drop that in the level. Now, if we actually test, we can see the radius that we're in. So that's the 2000. So if we enter that, it detects the character. Now again, 2000 might be quite a lot. I'm probably going to shrink that down to about 1000 just for the tutorial. Again, this is a value that you can tweak yourself. And again, you can also modify that independently on the component itself. So that's a little bit shorter now. Now let's jump back to, let's close some of these things at the top. Now, with that done, the next thing we want to do is actually loop through these hit results. So we can drag the local variable in, and we want to do a for loop, well, for each loop. And we connect that to then 1, like so. Okay, so the next thing we need to do is, on the array element, we can go ahead and break the hit result, and we do want to get the hit actor. Now, personally, I'm not a fan of how bulky this particular node is, just for getting one thing from it. So I am actually going to just collapse that to a function, and I'm just going to call that one get hit actor. You don't have to do this particular step, it's just something I'm going to do here. I'm just add a return node and just return the hit actor. Like so, and then I'm just going to make that a pure node as well. So that's just going to get the hit actor from the hit result we pass into it. Now we've done that, we do need to create another function. So in this particular bit, what we're going to do is do some calculations to determine whether or not the actor itself is actually looking in the direction of the owner of this. So we're going to go ahead and create a new function. And for this, I'm going to call this one check look at rotation. There we go. Now for this, we're going to need 2 inputs on this function. So the first one, I'm just going to do that as an actor type. And I'm going to call this one target actor. And then for the second input, this is going to be of a type float. And I'm going to call this one error tolerance. There we go. I think I've spelled that correctly. I'm not sure whether or not error tolerance is necessarily the correct phrase, but it's kind of you kind of think of it as the angle from center, well, not quite center. I think it's like the view range, the view angle, as it were, that's acceptable. I'll hopefully make a little bit more sense in a second. Now, from here we can then go ahead and add a return node, and this does need an output of a tap ball, and we'll just call this return value. Like so. Now what we need to do is actually start getting some of the data from the things that we're passing in. So the first thing we can do is from the target actor, we can get the actor rotation. So in this example, the target actor would be the player. If you're doing something more like a first-person type game, where you want it to be based on where they're actually looking, instead of using the get actor rotation, you could always get the controller and possibly get the control rotation instead, assuming you're using the control rotation to determine where the camera is. So this is kind of the thing that you can tweak a little bit. Once we've done that, we want to check if it's equal to another rotation. And the other rotation here, that's going to be the look at rotation. So this is essentially going to be the rotation from the target actor to the owner of this component. Now we can go ahead and just connect the return value there, so the ball to return value in the function. And then here we have the error tolerance. So we can just set this to the inputted variable. So, and we'll sort that out in a second. And one last thing we can do in terms of the actual input is on the error tolerance, you can specify a default value. So I'm going to go ahead and set that to 30. So that kind of sets that by default, and then when you're using the node, so if I drag that in, you can then change that value if you wanted to. Okay, so what we need to do now is set the start and target locations for this find lookout rotation. So for this, we want to get the actor location. Like so. Again, depending on what you're wanting to do, you could always change this particular location to be a bit more specific, like the head, for example, if you wanted to. For this, I'm just doing it based on the actor. And then for the target, we need to get the owner of this component. So again, you want to make sure the target is the actor component. And then we want to get the actor location from that. And then we can connect that straight in, like so, to the target. So this is kind of gets whether or not the target actor is looking in the direction of the owner of this. So that's what we're wanting. So we're going to drop that in. Now at the moment this is just a non-pure function, but I'm going to go ahead and make that pure. That just removes the exec pins on there. Okay, so now we've done that, we can do a branch on here. That's so. So in terms of this here at the moment, this itself would work in a sense, however, it would kind of have the same issue with the was recently rendered, in the sense that it wouldn't take into account if the actor is actually obscured by anything. So we do want to try and tackle that a little bit as well. So what we want to do now is actually check, what I want to do now is actually check for obstacles. So what we're going to do is go ahead and create a new function. I'm going to call this one check for obstacles. Like so. And this one does need an input as well. And that's going to be of type actor. And for the name, that's just going to be target actor again. And this time, what we want to do is a line trace. I'm going to use line trace by channel this time. And generally, we're searching for the visibility channel. So we're going to essentially trace from our target actor to the owner of this actor and see whether or not anything's in the way. If we don't hit anything, or it hits the owner, then we're good to go. They're being looked at, essentially. So we can go ahead from the target actor, we can get the actor location again. We can connect that up to the start. And then for the end, we want to do get owner. And we can do the get actor location from the owner as well. Like so. And in terms of all these other settings, generally we can leave those alone. I am just going to set the debug type for one frame, just so you can kind of see what's going on. And then what we want to do is, from here, we can do a branch on the return value for the line trace. So this is whether or not it's actually hit something. Now, if it hasn't hit anything, we can just return. And on the return itself, we do want to add an output, and that's going to be a type bool. Again, we'll just call that return value. Like so. And if we don't hit anything, then we can say there's nothing in the way. So we'll do a true. If however we do hit something, we kind of need to check what we've hit. So we can do the get hit actor again, and we can check if that's equal to our owner. So again, we're getting the actor that owns this component. And if we've actually hit the owner, And then again, we know that there's nothing in the way, there's no obstacles. So we can kind of just return whatever the result of this is. Just like that. Now jump back to the get nearby, we can connect in the get obstacles. So from the branch on the check look at rotation, if it's within range, we can call the check for obstacles, and then we can go ahead and just connect in the target actor. Like so. And then we can do a branch on there as well, so we can do something in a second. Okay, so now the next thing we kind of need to do is update whether or not, well, we need a variable essentially to keep track of whether or not something, our owner is being looked at. So what we're going to do is actually go ahead and create a new function. This is going to be called set is in sight. Again, you can call these functions whatever you like, as long as you know what they do. And we want to add an input on there. And I'm just going to call that one in view, just so it's a little bit different from the variable in a second, just so we know which one's which. And then we want to go ahead and add a new variable to the component itself. So the variable, it's not a local variable, so it's the main one. And I'm going to call this one is in view. Actually, I'll do this one is, I'll do the one, actually, I'll do it as in player view. Again, you can name these whatever you like. Now, what we want to do is actually check, is the incoming value that we're trying to set it to, is it already equal to what we have it set at? And the reason we're doing this is because we only actually want something to happen if it's different, essentially. So that's going to kind of help us facilitate that. If it's different, we can come in and then set the in player view to the in view input variable, like so. The next thing we actually need to do is, well, certainly the way I'm going to be doing it, and that's using event dispatchers. So the way we're going to communicate out that something's changed is by using event dispatchers, so things can bind to it essentially. So that way this component doesn't need to know about anything else other than the thing that it's supposed to be doing. So for that, we're going to go ahead and create a new function. I'm going to call this one notify site state. And we can get the in player view variable in, and we can do a branch on that. Like so. And now we need to go ahead and add 2 event dispatchers. You could probably get away with just one and pass the variable through, but in this example, I just like the idea of having 2. So the first one is going to be called on is sighted started. And then the next one is going to be on is sighted ended, like so. And then we'll want to drag these in and call them essentially. So is player view, if that's true, we can do the started, and if it's false, we can do the ended, just like so. Now if we go back to the set is in sight, we want to go ahead and actually call this at the end here. So whenever we set this variable to anything, we then call the notify site state, so that way it'll only ever call this when this is updated. Adding to that, what we probably want to do as well, this particular variable here, the in player view, we want to go ahead and make it private. And that means that you're not going to be able to change this variable outside of this component. And the reason we want that is we don't want anything external from manipulating that value, because it should only be this component that ever sets it. However, there may be scenarios where you want to get that value. So with us making it private, let's quickly go ahead and create a getter function as well. So create a new function, that's going to be get is sighted. Again, you can call these whatever you like. And we'll add a return value, And all we want to do is just return this particular value here, so the in player view. And I'm going to go ahead and make that a pure node as well. So just so you see, that's what that's going to do. So that just gives a way for something external to this component. If it does need to know what that value is, it can go ahead and get it. It just won't be able to directly change it. Okay, so now let's go back to the check nearby function, and now we need to call the set is inside. So for this, if check for obstacles, if the value on that is returned is true, we want to go ahead and set the in view to true. Now, I know the name of this is for check obstacles. The return value in terms of the true or false might not make sense for the name, so you can always flip these if you wanted to. In terms of this node now where it's set is in sight, if we do actually call that at this particular point, we can go ahead and just return on the function. So what that's going to do is it will essentially stop it from looping through anything else in the list, because if we know it's already, something's already looking at it, we don't need to look at the other ones in the list. Now the last thing we kind of want to do as well is we're just going to copy this set is in sight, and we're going to connect this up to the then to. So let's move this down a little bit. So if we've actually been able to get all the way to this particular point, it means that there was nothing in this list here that is looking at it, so we can set the insight to false. Just like that. Now in terms of what we're doing here, if we actually go and test that now, you kind of notice that we're in range, but then when we face the character, we do get that line trace. So if something was in the way, let me just quickly add something, an obstacle. Probably make that a little bit taller as well. Yeah, so if we look at the character like so, then if we stand by here, around here and do it, you'll notice that it's detecting that there's an obstacle, so that would affect the visibility. Although again, in terms of the trace locations, you might want to do that from the head. Obviously at the moment I'm just doing it from the actor itself. And let me just move this again, so we're not blocking the spawn. Okay, so one last thing we probably want to do is on the begin play, we probably want to notify the site state. So that's when we first start the game. It will just do whatever the value is here. And this will make a little bit more sense in a second. But in terms of this component, it's done. It should be doing what we expect it to do. Now if we come to the pawn or character or whatever it is that you want to use this component, so if you remember we've already added that in, we can then right click on the component, and under the add event section you should see those two event dispatchers that we created. So we can add both of those in. Like so. So the top one is unsighted. And in this example, what we want to do is determine whether or not we want to have the character move or whether or not we want them to stop. So I'm going to have a variable here just to keep track of that. So I'm going to do is moving. Again, you could have other ways of handling this if you wanted to. So if the thing is sighted, then we want to stop movement immediately. So we can use the movement component with this particular one. Again, if you're using just a pawn, you probably need to handle this a little bit differently. But with this being a separate component, it does offer that sort of flexibility to do that. And once we've done that, we can then just set the is moving to false. And then on the site ended, we want to do something similar. This time, however, we only want to do something if it's not moving. So for this, we can do an AI move to. Don't want to use that one. Yeah, that should be okay. Is moving false. And we'll set the is moving to true. Actually, no, that's not the one that we want. There should be another one. AI move to. I think what we're going to have to do is get AI controller. And we just want to connect self into that. So we're getting the AI controller of the Weeping Angel essentially. And we want to use the move to location or actor. And the reason we want this one is because it gives us a couple more options. So there is one here for continuous goal tracking. And that means that if the target moves, this will move as well. It'll update the location. So is moving, if that's false, we can come into this node. We'll set the is moving to true. So everything else there should be okay. Now for this we're going to use the goal actor, and I'm just going to go ahead and use the get player character. Now this itself ultimately you would probably replace with something that determines which actor it should be following. So it might not always be the player, particularly if you're wanting it to follow NPCs as well and possibly have them interact with it in some way. Similarly, if you're doing multiplayer, again, you might want to choose which player, but that's kind of where you'd possibly change it. You might have to do something different to handle that. Okay, so that itself should, for the most part, do its thing. Oh, yeah, so you can see it's currently chasing me. I'm not sure. It's very quickly. Let me turn the movement speed down. Let's drop the max walk speed down to half. So that's trying to follow me. And if I look, it stops. Just like so. Now, one thing that I probably do need to mention is that in this particular level I do have a nav mesh bounds volume. Now if you're using anything with the eye, you do need to have a nav mesh volume if you want to use the nav mesh. So you can press P and it kind of shows you the green sections that are generated. So the AI itself will only be able to move on the green bits. So it's just something to be aware of when you are setting up these move to nodes. If you're wanting to handle the movement differently, you might not need to worry about it. But yeah, for this, again, all I did was just place it in the level and set its size to cover a particular area. Okay, so in terms of the component, it's pretty much done as you've seen. However, there are probably a few additional things we're probably worth adding that you might be able to utilize in other places. So one of these is kind of enabling and disabling this particular component. So you may notice in the sort of initial example at the beginning, I had it set up where it only actually affected anything after a certain time of day. So when it's outside of the range, it essentially disabled the tick on this particular component, so it didn't do anything. And then when it entered the correct time range, then it enabled it. So we can kind of do that as well. So for this, we're going to do set enabled state. So this is a new function inside the component, and we're going to add an input, and that's just going to be a type ball, and I'll click on new active state, and we're going to do a branch on there, and then we can do the set component tick enabled, like so. So the top one would be true, so enabled, and the bottom one would be false. Now, some of you might be thinking, why didn't I just connect that up? Because that's all we're doing. And the reason why is because you may want to do other things when this happens. So for example, if this component becomes disabled, we might want the owner of it to do something as well, or whatever that is. In my example, I had it set up where if it is moving, it stops the movement if it gets disabled. So we might want to do something similar there. So again, we can do an event dispatcher for that. So I'm going to do on enabled state updated. Again, you could do two separate ones if you wanted to. This one's going to have a value. It's going to be new state. And then we can just call the event dispatcher. Like so. If you wanted to, you could always have a separate variable to keep track of whether or not it's enabled. For us, because everything, well for me, because everything happens on tick, if this is disabled then the tick's disabled, and there is a very handy option on here for getting the component tick. So is component tick enabled? So you can kind of just use that. Again, depends on how you want to handle it. So yeah, so with that event dispatcher, we can then right click and you should see that on there as well. So what I'm going to do is, we'll just bring this down just so this is above it a little bit. And on here, I'm just going to do a branch. And if that's false, I'm just going to connect it straight to this section here, which is what stops its movement. So it'll check, is it moving? If it is, then it's going to stop the movement as well. So that way, if we do ever disable this component when it's moving, it'll stop the movement essentially. So yeah, so that's pretty much it. So what we'll do, just as a quick test, begin play. I am actually just going to disable I'll say that. What did I name it? Set enabled state. There we go. Again, so this section is just for debugging. I'm just going to add a quick delay. Yeah, so 10 seconds might be a little bit long. So after 5 seconds, it's going to just disable the component. So assuming it's chasing me at that particular point, it should then stop as well. So we should be able to test that. So we'll just keep out of its range. Yep, and there you go, it stopped. And you'll probably notice the debug spheres have stopped as well. So the whole component's now not doing anything. So yeah, so that is the component. One last thing I will quickly show as well is just how I set mine up. So as I mentioned, I have a day-night, like a global clock sort of system I've been working on. So I've been using that to set the states. So yeah, in this particular example, I just had 2 separate event dispatchers for whether it's active or deactive. But as you can see, it's pretty much the same thing. There's not anything different. So yeah, hopefully you've found this video useful. But yeah, I do just want to say I do have a Discord channel, so if you want to have a chat about anything or you need any help, by all means go and jump on there. Also, I do have Project Sunrise on the marketplace, although Fab, I keep saying marketplace. So if you're looking for an interaction system, a dialogue system and a quest system, be sure to go ahead and check that out. It's all blueprint based, so you've got lots of flexibility in terms of changing and tweaking things. That's it. Also, I have a Ko-Fi page, so if you'd like to support me, you can do so through there. But yeah, I just want to say again, thanks for watching and enjoy the rest of your day.